Good evening, everybody, and tonight we're going to be talking about complex numbers, how to solve them, what they are, what they mean, and the things associated with them. So, get your pencil, get your notebook, take notes, and let's get started, shall we? So, first things first is that you need to know what an imaginary number. You've all been told that in the past that there are no square roots to negative numbers and that they don't exist. But now we are going to learn that an imaginary number is defined as the square root of a negative number. So the square root of -1 is expressed through I. And I is going to be our home base for all these imaginary numbers. So I squared is going to equal -1. I cubed is going to equal -I. And I to the fourth is going to give us +1. So now that we know an imaginary number, now we can discuss a complex number. And all a complex number is when you combine a real number and an imaginary number. A real number being like 1 or 2 or 3 or pi. So the combination of a real number and negative numbers, and we can express it through A plus B and I. I is our imaginary number. I is our imaginary number. And then A and B are real numbers. So then I'll give you an example. 2 plus 3i. That's a complex number. And another example could be 11 minus, let me erase that. Minus the square I and the square of 7 and 8 minus 5i. So that's all complex numbers are. Now we can move on to our conjugates, and a conjugate is it's just a complex number. Let's use one from the previous slide. Let's use 8. What was it? 8 minus 5i. And all you do is that you change the sign. So it's going to be 8 plus 5i. And here's some more examples. 9 minus I would become 9 plus I. Negative 27I would become 27I. And I plus the square root of 13 would become the square root of 13 minus I. And you're always going to put the real number first because math grammar. So A plus BI is going to become A minus BI. And vice versa. So that's that. Now here's our first look at simplifying complex numbers, and you don't want to freak out or overthink the I part. Just treat it like an X. It's like an ordinary X. And so we're going to start out by combining like terms. So here's an I. Here's another I. Circling the I's, like term. And then the other like terms. Real numbers. 13 and 32. So here, we're going to start out with the real numbers because of math grammar, and we're going to put the 45, and that's going to get us positive 11i. And that's going to be our answer. So fairly easy. You use subtraction and addition to get the answer. But this one incorporates some multiplication because you have the negative in front of the parentheses, so that's going to change this guy and that guy. It's going to change their signs. So what we're going to have is minus 4 minus 15i plus 5, because we switch the sign, minus 6i. So we're going to combine like terms, and here we're going to have 1 minus 15i minus 6i, negative 21i. That's another answer. Now this one's a little more in depth because you're going to start out by multiplying them, and then you're going to combine like terms through addition and subtraction. So take a moment, pause the video, and solve the problem, and I'll see you on the other side. So you should have solved it, and here's what part of what you should have done. I'm going to help you out with the combining of like terms. So you're going to be left with 6 minus 6i plus 8i minus 8i squared. And you're going to combine these two, and you're going to be left with 6 plus 2i minus 8i squared. And if you recalled earlier in this video, I said that I squared was equal to negative 1. So we can replace the I squared with negative 1. And to further simplify this equation, we use negative 1. And 6 plus 2 is 6. Well, that's positive 8. Sorry. The 2 i's going to be over here. And that's going to leave us with 14 plus 2i. And now here's the dividing of complex numbers. And as I said earlier in the video, what's it called? The conjugate is going to help us with this. So the conjugate of 4 plus 2i is 4 minus 2i. And don't forget on top 2. And after you've FOILed them or used the box method, you're going to be left with 8 minus 8i plus 6i squared, right? And on the bottom, you're going to be left with 6 minus 4i squared. And after you've combined like terms and all that, you're going to be left with 2 minus 8i, 8i, and then on the bottom you'll have 20. But then you want to simplify the 2 and the 20, so you're going to be left with 1 minus 8i, and that's going to be a 10. So you would leave your answer as that, and that'd be your answer. So now, the discriminant of an equation is b squared minus 4ac. And this equation comes from the quadratic formula, and each discriminant is determined from the given quadratic equation, ax squared plus bx plus c. And the discriminant helps us determine the number of zeros or solutions or roots, whatever you want to call it. And it helps us determine the nature of these roots, whether they're real or non-real. So an example of how we would use it is, here's a quadratic equation, negative 2x squared plus 4x minus 3. So after you plug this in to this discriminant template thing, you're going to be left with negative 8. And what does this negative 8 mean? It means that we have two non-real solutions. There, abbreviation. And this next slide is going to help you understand why. So take a minute and copy this down onto your notebook and familiarize yourself with this. And this shows you why negative 8 had two non-real solutions, because it was less than 0. So that means we have two non-real zeros or solutions. So here we're going to put that skill to use, and here this equation is in the vertex form. And we know that the vertex form gives us the vertex with these right here. So 3 and 7 is going to be a vertex. And if you take just a minute or a few seconds to sketch it out, 2, 3, 1, 2, 3, 4, 5, 6, 7. Your vertex is going to be here, and here's going to be your parabola going all the way up there. So this is going to shows us that we have this space over here, and it tells us that we have two non-real solutions. Okay. So right here, we're going to solve by factoring. We can factor to solve a quadratic equation. And by solving, we'll get the roots of the equation. So here's an example. X squared plus 11x plus 24. So we're going to set this up over here. B, a champion. And the 11 right here. And the 24 over here. So 3, oops, not plus, because you're multiplying. So 3 times 8 gets us 24, and 3 plus 8 gets us 11. So now we plug those in over here. X squared plus 3x plus 8x plus 24. So after you've done your factoring with them, you're going to be left with x plus 3 and x plus 8. If you set these equal to 0 and solve, you get x, this x, is equal to negative 3, and this x is equal to negative 8. So by doing this, we get our roots, and we solved it. So that's it for tonight's video, and I hope you took good notes, and yep, good night.